Everyone, so let's take a look at the second problem. First, let's draw a picture of the translation matrix, and that is going to be if at the status of xk, there's two status. One is xk and the other is xk plus 1. So let's suppose so when xk is equal to 1 and xk plus 1 is equal to 1, the translation function is going to be 0.6, and x1, this is going to be 1.4. And if xk is equal to 1 and it translates to it changed to 0, that is going to be 1.3, and if 1 to 1, and the probability is 0.7. So the first problem asks us the probability of x2 is equal to 1, and that is going to be probability of x equal to 1 given x1 is equal to 1 plus x1 is equal to 1 and x2 is equal to 1, x1 equal to 0, x1 equal to 0. This is the this if we submit the if we substitute this term in find the value on this map, we will find that it is equal to 0.7, and this term is 0.4, and px equal to 1 is 0.8, and this is 0.2, obviously. So that is equal to 0.64. And since px2 is equal to px1 equal to 1, x2 equal to 1, the probability of this term is 0.64. The probability of x2 there is equal to 0 is 0.36. So using the same strategy, we have probability of x3 is equal to 1 is equal to px3 equal to 1, x2 is equal to 1, and x2 is equal to 1 plus x3 equal to 1, x2 equal to 0, and the probability of x2 equal to 0. And then we use the map again, and that is going to be 0.7 plus 0.7 and 0.464 and 0.4 multiplied by 0.36, and that is equal to be 0.592. So, and let's take a look at the third one. Here we want to find out the probability of x equal to 1, 0, given x3 is equal to 1. So this is not straightforward, so we have to use if we use the base rule, that's going to be much more simpler. So yeah, that is using the base rule, we have probability of this term is equal to x1 equal to 0, x3 equal to 1. Okay, and x2 equal to 0, and it is multiplied by plus by x1 equal to 1, x3 equal to 1, and x2 equal to 1. This is divided by x3 equal to 1, and if we extend this term using the chain rule, we have to 1 and x2 equal to 1 plus x1 equal to 0 and x2 equal to 0, given, not given, and this is going to, if we extend this term, this is going to be p x1 equal to 0, given x2 is equal to 0, given x1 equal to 0, and plus, and multiply x1 equal to 0, and plus x3 equal to 0, x1 equal to 0, x2 equal to 0, x2 equal to 1, given x1 into 0, x1 equal to 0, divide px3 equal to 1. Okay, let's take a look at this term and this term. If x2 is, if we give x2 is equal to 1, then the state of x3 is independent with x1, right? So this term we can cancel this x1 term, and after that we can, substitute the map into this function, and this is going to be 0.4, 0.6 multiply 0.2 plus 0.7 plus multiply 0.4 multiply 0.2, and divide into 0.592, which is solved in the last sub question, and this is equal to 0.176. Okay. Okay, so the final question is asking what is the probability of px infinity equal to 0. Okay, so let's denote xn equal to 0 is pn. So assume, so this term, if we use the method we are familiar in the last three questions, and this is equal to xn equal to 0, xn minus 1 equal to 0, and multiply x1 n minus 1 equal to 0, plus pxn equal to 0, given xn minus 1 equal to 1, plus and multiply xn minus 1 equal to the 1. So if we use, in this denote, we can write this term into n into 0.6 pn minus 0.3, 1 minus pn minus 1, and that is 0.3 plus 0.3 pn minus 1. Okay. So this is the relationship between p minus n minus 1 and pn, and if we solve this function, and we have pn is equal to minus n 0.3 n and p0 0.3 plus 1 minus 3 n 1 minus 0.3, that is 0.3, and if n is going to 0, and this term is going to be 0, and this term is going to be 0, and that is going to be 0.3, 1, 1 minus 0.3. That is 3 of 7. So that is the total solution of the question 2. Thank you for watching.